Question 2.5. Two infinite non-conducting plates are parallel to each other with a distance d equals 10 cm between them. Each plate carries a uniform charge distribution of sigma equals 4.5 microcoulomb per meter squared. What is the electric field at a point P with xp equals 20 cm? So here you have two non-conducting plates. Both of them have a charge density of sigma, and sigma is equal to 4.5 microcoulomb per meter squared, which you can write as 4.5 times 10 to the power negative 6 coulomb per meter squared. Distance between the two plates is 10 centimeter, and you need to find electric field at a point P, and position of point P is 20 centimeter. Now, before we find the magnitude of electric field at point P, we first need to show the direction of electric field at P because of the two plates. Both plates have positive charge density sigma, so electric field because of both plates will be coming out of the plate. So you can show electric field coming out of the two plates in this manner. And at point P, electric field because of both of them will be going to the right. So this will be electric field due to plate 1 at point P. We will call this E1. And then this will be electric field at point P because of plate 2. We will call this E2. Let this be plate 1. Let this be plate 2. And at point P, both electric field will be going to the right. So I can calculate the net electric field at point P, E net, to be a vector sum of E1 and E2. Now we know for an infinite non-conducting plate, electric field at any point on the plate is given as sigma over 2 epsilon naught. And this electric field is independent of the distance from the plate. It depends only on the charge distribution and the permittivity of free space. So electric field at point P because of plate 1 and plate 2 will have the same value because they both have the same charge distribution, and this value of electric field does not depend on the distance from the plates. So I can write here for E1 and E2 as E1 will be sigma over 2 epsilon naught. Same with E2, sigma over 2 epsilon naught. When you add them, you get 2 sigma over 2 epsilon naught. Cancel off the 2, and you are only left with sigma over epsilon naught. So now we will substitute the value of sigma and epsilon naught to find E. Sigma equals 4.5 microcoulomb per meter squared. Epsilon naught is 8.85 times 10 to the power negative 12. And when you solve this, you get the electric field to be equal to 508,474 Newton per coulomb, which you can write as 5.08 times 10 to the power 5 Newton per coulomb. This is the magnitude of the electric field, and this electric field is directed towards the right, so you can write the direction as right. And you can also rewrite this expression in vector form. We write E net equals 5.08 times 10 to the power 5 x cap Newton per coulomb.